Hello good day viewers. In this tutorial we are going to learn how to evaluate one-side limit of a radical functions. If you observe, all of these are square roots, and while dealing with square roots you don't want any situation that will make the radicand to be negative. All of this should be positive, otherwise they are said to be imaginary. Alright, let's start with the first one. We would like to evaluate the limit of the function the square root of x as the value of x approaches 0 from the right. What does this mean? It means, suppose we have a number line here, this is 0. We are approaching this 0 from positive infinity towards the 0. And you should know that all these values will be greater than 0. So you will not have any problem substituting any value here greater than 0 because it is defined. So therefore we can substitute 0 directly and this will give us 0. Therefore, if you evaluate the limit of the square root of x as x approaches 0, it will tend to 0. And this 0 should be the value of y. Let us sketch it on the graph and see. Suppose we have y-axis and x-axis here. Graph of square root of x looks somehow like this. So what this is saying, we are approaching 0 from the right. This is the right direction, right? So we are approaching 0 and this is 0. And that 0 should be the value of y. So as you approach 0, somehow like this, you're going to approach 0 directly, and therefore the solution to this problem is 0. Now let us take the second one. So here is the second problem. We would like to evaluate the limit of the function the square root of 1 minus x as the value of x approaches 1 from the negative direction, that is from the left hand side. Suppose we have a number line here, this is 0, this is 1, this is 2. If you come to the other side, you have -1, -2. And this is the number of interest, which is 1. So we are approaching 1 from the left-hand side. All right, let us find the domain and see whether this is true. You know, definitely 1 minus x should always be greater or equal to 0, which implies that 1 is greater or equal to x if you take -x to the other side. And you can always switch it as x less than or equal to 1. So therefore, any value you take which is less than 1 or equal to 1 will satisfy. So you can see all these values to the left hand side are less than 1, right? Therefore, this limit exists. So what happens if you substitute 1 directly? You're going to have 1 minus 1, which is 0. So this will approach 0 directly. Let us sketch it and see. One thing you should know is that square root of 1 minus x is also the same thing as the square root of, you can factor out negative sign, then inside it is going to become x minus 1, right? If you expand this, you shall get this back. So let's sketch it. We have the y-axis, we have the x-axis. This is what we need to sketch first. Remember that the square root of x looks somehow like this, but there is a horizontal shift 1 unit to the right. So 1 unit here, it is going to look somehow like this. But because of this -1 outside, there will be a reflection. So it is going to turn to the other direction from 1. This is 1, remember. So our limit as x approaches 1 from the left hand side. So this is the left hand side. As you approach 1, y will approach 0 because y is only 0 on x-axis, right? So you can see that our limit is equal to 0. And one thing you should remember here again, if you're approaching this one from the right hand side, there are no other values towards the right hand side. Therefore, our limit from the right does not exist. The same thing to this one. If you're approaching 0 from the left hand side, there are no other values because all our domain are towards the right hand side. So the limit from the left hand side does not exist from this other problem. So now let us take the last one. So here is our last problem. We would like to evaluate the limit of the function the square root of x minus 5 as x approaches 5 from the left hand side. This is what it means. Suppose we have a number line here. We have 0, 1, 2, 3, 4, 5, 6, -1, -2 in that order. So our number of interest is 5, but we are approaching this 5 from the left hand side. You can see all values to the left hand side are less than 5. Is that true? Let us find out. X minus 5, which is the radicand, will always be greater or equal to 0, which implies that if you take negative 5 to the other side, we have x greater or equal to 5. But these values here are less than 5. But our domain is x greater than 5, which implies that the limit does not exist. But let us sketch it and see. If you have square root of x minus 5, that's a horizontal shift 5 units to the right, right? So we have y-axis, we have x-axis, 1, 2, 3, 4, 5. This is where it is going to start. So we have something like this. Remember, this is 5. So as you are approaching this 5 from the left hand side, there are no other values to the left hand side, unless if you are approaching to the right hand side, which implies that the limit does not exist. But suppose we are approaching from the right hand side, our limit will be equal to 0, right? Therefore, we say that the limit does not exist. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.